Okay, so our webinar today is from poison pickles to bad patches, unpacking Q1's software supply chain threats. Welcome, everybody. Again, my name is Paul Roberts. Lucia and Karlo are our guests here to talk about their discoveries. Before we get going for the audience, Karlo and Lucia, maybe just take a second to explain to the folks kind of what you do here at Reversing Labs and what your superpower is, as it were.
So I'm a threat researcher at ReversingLabs for a couple of years now. I'm searching on NPM and Ruby gems for malicious packages, and if something is more interesting or something is new, I make more in-depth analysis about it and then make a blog about it.
Very cool. Karlo.
Well, I've been working at ReversingLabs for more than 6 years now. I'm working on threat research, and our day-to-day tasks include finding malicious packages in open source repositories, mainly in PyPI, and we are also trying to make new rules for automated detections and support detecting novel attack techniques, and here and there write a blog about something is fine.
Thank you. So our research this quarter really interesting and kind of diverse. The two reports we're going to talk about, one from you, Karlo, and one from you, Lucia, deal with malicious models in the Hugging Face AI platform, as well as some malicious NPM packages stealing crypto assets. Let's start with the Hugging Face discovery. This was one that we published back in February, and Karlo, these were packages that you came across. To talk about what you found, in particular, kind of what was it that caught your attention or got onto our radar here about these packages on the Hugging Face platform? And for folks who don't know, maybe just take a second and explain what Hugging Face is.
Yeah, Hugging Face is a platform where ML researchers can share their models, data sets, and everything that is related to machine learning ecosystem, and it's generally a platform that supports mostly all actions related to ML model development. And basically what people do, they share their models and collaborate on them, like on a GitHub repository or something like that. Basically, you upload projects and other people download them and use them. And what we came across are malicious ML models. How we came across them? Well, basically, we were improving our Spectra platform with new features so that we could detect malicious behaviors in ML models. And when we tested what we developed, we came upon some real-world malware examples.
And these were in these files called Pickle files. These are serialization files. And these have been flagged before as files that carry serious risks with them because of the way that they were sort of designed. Just explain briefly kind of what Pickle files are and the nature of the security risks that you discovered. Well, the malicious code that you discovered in these Pickle files on Hugging Face.
Yeah, well, basically, Pickle file format is a serialization format. So let's say you have one process where you execute your code, and you have some objects that are part of that process, and you want to share that objects to another process which doesn't know anything about your environment, doesn't have access to the same memory. So what you need to do is to serialize those objects in some way so that in the other process, in the other environment, you could deserialize them and get the exact representation of the object. Well, basically, where the problem is that this serialization format was when it was designed, it was thought to be used for communication between processes and, let's say, from trusted sources. You have your trusted environment and you share data across it. Now, where it ended up being used, it ended up being used on a platform like Hugging Face, which in its design, it takes collaboration of different people which don't know each other, which can't trust each other, and they share their serialized objects through Pickle file format. So basically, you have something designed to be used in trusted environment, and now it ends up being used in open source environment where anyone can share anything they want. And of course, moderators sense that kind of opportunity, and they tend to abuse it.
So explain for us if these malicious ML models had been downloaded or were downloaded, how exactly would this attack play out? Is it indistinguishable from any other, open source, compromised open source package that you might download and integrate into an application? And
Well,
is the attack basically the same?
The concept is the same, but for you, like a user, when you download the PyPI package, NPM package, or anything like that, you're downloading executable code, and those scripts are supposed to run some code, and you're at least a bit aware of that risk. With ML models, you think, okay, this is just serialized data. This can't hurt me, because most of the people don't know how ML models, data sets, and everything that functions. So basically where the problem is, Pickle files during the serialization provide ways to execute some type of code. In this case, it was Python code, since Pickle files are related to PyPI, to Python code. So basically the main problem is people aren't expecting ML models to execute code. They are expecting it to be just data.
Right. And to be clear, Hugging Face has a tool, a security tool called Pickle Scan that is designed to scan and assess Pickle files for security flaws and other issues. But one of the things you discovered is that there was a hole in its detection that allowed this malicious code to be executed, right?
Yeah, what the attackers tried to, why these samples were interesting compared to a lot of other Pickle serialization proof of concept malware that were discussed all the months before, because the story about Pickle insecurity is not something we came up with, it's something which is already known. But what was interesting in our research was the fact that the malicious actors try to take a novel approach and bypass detection mechanisms which were implemented on Hugging Face by abusing the way security tools Hugging Face provides are designed to work, compared to the way Pickle deserialization works. So basically, how Pickle deserialization works: you have a stream of data, you go through the stream, take part of the stream, deserialize it, execute everything that needs to be done, and do that until you reach some broken Pickle instruction, opcode, or until you reach end of file. How security tools work: first, they verify that the entire serialized stream is valid, and if it is valid, then they perform security assessment of parts. If it's not valid, they won't do security assessment. So
right. So are there, Hugging Face itself kind of tries to steer people away from using Pickle files, recognizing the security issues. Are there other serialization formats that developers can use, or ways of scanning that would, as a developer, make you aware of, oh, hey, there's malicious code in that serialization file?
First, to confirm, Hugging Face, we reported the issue to Hugging Face. They were quick to implement a fix in Pickle Scan, and also to provide warnings to the users. There are a lot of pages, a lot of materials where Hugging Face as a provider makes users aware of the risks related to Pickle. They are saying all over, don't use Pickle, but because most of the users are still deciding to use Pickle, they had to find a middle way. And basically, what they also did, they tried to provide other formats. They are promoting safe tensors, for example, as another format for data serialization, deserialization, which is much safer than Pickle. And there are basically all serialization formats are in some way safer than Pickle.
Right. So what would you say to developers who are who are working on platforms like Hugging Face, looking obviously to leverage the huge kind of open source, shared work that platforms like that offer, about what they should do, how they should assess the risks of some of the file components that they're using. Like, how should they maybe change what they're doing? Because I think one of the things is there's a little bit of magical thinking about AI and ML, that this is all everybody's just working for good out there, but in fact we're already seeing malicious actors start to gravitate towards these platforms. So how should developers kind of change or look at the work that they're doing and assess the risks involved?
Yeah, the base problem from security perspective is that people aren't aware of how ML related things work, and therefore they aren't aware of potential risks. People need to be educated more and to learn how those tools work. I understand those tools are complex, but if you are trying to do something with ML, and either you need to use security tools that will help you protect you from something you don't know how it can harm you. You need to either do that in sandbox environment or something like virtual machine for testing, or you need to learn where threats can come from. But basically, it's a complex problem. The whole ecosystem related to ML is really complex, and you should use dedicated tools to look at the potential risks from the files, all the files, not just executable files, models, data sets, anything can, let's say, smuggle malware into your development system. So scan everything if you're not aware how things work.
Where are we in terms of the focus on AI and ML development pipelines? I mean, clearly this is a malicious campaign. It's not really, I don't think we really understand fully who was behind it or what the purpose was, but are these becoming more common, or are they still pretty rare?
Well, I would say they aren't so common because the problem is attackers are always a few steps before the security community, and security community is just starting to hop on the whole AI and ML train and to develop improved tools. You need to have some time from the moment that some landscape becomes interesting for attackers, because before it provides possible piece of value for security companies, and the moment that their tools become mature. So we are somewhere in this phase of transition between unsecure and secure solutions for ML security.
Very interesting. Very interesting research, Karlo. Let me remind the audience, we'd love to hear your questions if you've got them. You've got two amazing malware and threat analysis experts on the line, so don't be afraid to, don't hold your questions back. Let's move ahead to the other major campaign that we wrote about in Q1, and this was one, Lucija, that you discovered, two malicious NPM packages that were targeting cryptocurrency users and applications. We're going to talk about that whole trend in a second. but used a very interesting method to implant malicious code. Talk about Lucija, these two files that you found, and kind of what, again, as with the Hugging Face, what put these on your radar to begin with?
So usually NPM packages malware found on NPM are info stealers, downloaders, but they themselves are serving malicious code or containing malicious code. This time, however, with this campaign and these two waves, those malicious file packages injected malicious code inside legitimate locally installed first packages, then softwares. So they were pushing malicious payload inside other softwares that are locally installed and that usually aren't scanned. They are just scanned like the first time when you install them, and then later usually aren't scanned. What put those malicious packages on my radar was usual behaviors. So first wave I discovered because there were some interesting behaviors found in post-install scripts. So usually, packages do have install scripts. It's nothing unusual, but it's very also common for threat actors to include malicious payload inside. So it's very useful to check install scripts. And for packages in the second wave, again, malicious payload was obfuscated with JavaScript obfuscator, which is not something that it's automatically, malicious. So if file is obfuscated, it doesn't mean it's malicious, but it's, it's very high likely it is. So it could be suspicious. So it's very good to look at it. So that's how I found those two packages, those two waves. And they were very connected, like a week after. So I was searching for that kind of trend on NPM as well.
Right. So it's always a red flag when either their name or the content of the file seems to closely mirror an established file. Then in this case, the file they were impersonating or targeting was one called Ethers. Is that right?
Yes. So the first wave had two packages, Ethers Provider 2 and Ethers Provider Z. The name was closely related with Ethers, which is a crypto related package. It also was injecting malicious payload inside a legitimate local installed package Ethers. The second one, however, wasn't connected with the name or anything with crypto community, but it did target crypto community and it did inject malicious payload into crypto-related softwares.
And Ethers, this is a top 10,000 NPM package around,
Yes.
190 million downloads in the last 4 years, 22,000 dependent applications. So this is highly used. So they had similar names. So this is kind of typo squatting, which you talked about. They use the word Ethers, which if you're a developer and in a hurry, you might just assume that they're all related or from the same development, group. What would they have done, or what did they do to try and get developers to download and install the malicious packages instead of the actual Ethers package, which is not malicious?
Well, depending on, so there are different ways they can type a squat. They can take names of the popular NPM packages and they can change few letters, or they can add letters or something. But there is also a type of typo squatting where they take the names of popular malicious and popular NPM packages and they kind of make wordplay on that. So we had campaigns where they took the names of popular NPM packages and they put legacy after the name. So they kind of conveyed, oh, this package is legitimate, it's just a continuation, but it was malicious.
Right.
So with these malicious NPM packages, they added, the word providers to the word ether. So, maybe developers could potentially think that it has to do something with ethers, and that package can help them. However, the package was mimicking or impersonating legitimate NPM package SSH
Yes.
too. So that has nothing to do with the crypto community. So I'm not sure why they chose SSH2 package and not something crypto related, but you know, that's for
Right.
me to know.
Is that sort of just an idea of like, you know, they're thinking if somebody wants to open this package and look at it, we're just going to throw a whole bunch of code that looks legitimate so that they don't notice the malicious code? I mean, is that kind of the idea behind why they might do that?
Yeah, sometimes they are try to write their own code, and sometimes and mostly if they're lazy, they just took the code, legitimate code,
Right.
and in the
Copy
one
paste.
copy paste the whole code from some legitimate NPM package, and then in some file they add their own malicious payload, sometimes hidden, sometimes not, sometimes the malicious payload is obfuscated, sometimes is just base64 encoded. You know, sometimes well it's hidden, but you know, if you know that the package is impersonating the legitimate package, you can make a diff and you can very easily
Right.
see what was added.
What's changed, right?
What's changed, yeah.
So in this case, like you said, often with NPM packages or malicious Python packages, there's a set group of behaviors that are characterized malicious files, post-install scripts, stuff like that. You know, external communications, you know, talking out, sending data out. Those are all things that we're used to seeing, but these packages had a somewhat different delivery. What they did. Talk about what they did once they were installed and how that potentially could make it harder to detect these, you know, malicious packages if you were to download and install them.
So those two waves were different. They were both patching legitimate local install software, but they were different. So the packages from the first wave, they were downloaders, and basically they would inject Trojanized files into locally legitimate installed NPM package ethers, and that malicious payload would download reverse shell. So malicious actor would gain an access to a computer if the victim had ethers installed, or if it installed ethers in any time. The victim would have reverse shell without the victim knowing. And for the packages in the second wave, they were very simple, and they would inject malicious payload inside software atomic wallet and exogenous wallet. And that malicious payload Trojanized files would switch out outgoing addresses for crypto funds. So for example, if you're a user and if you're using Atomic Wallet, you have some crypto funds, you want to send them to somewhere, to your friend or to some user, other user, you would of course use Atomic Wallet, but the outgoing address would, without you knowing it, would get switched out for malicious threat actors crypto wallet address. So the funds would actually redirect to the wallet of to totally different address, to totally different wallet. And that is a little bit hard to detect, because when you install things, when you know, you're trying to be mindful, you're trying to know what you are including in your development cycle. So you know, you maybe scan everything, you maybe check everything, but for already installed software that you know that you use every day, that you know is, you already checked it, you know it's safe. For that to be Trojanized, it's a little bit harder to detect, because you wouldn't check, you wouldn't notice anything happens, you know.
And when we say they patched these files, is that, did they overwrite the files? Did they append information, you know, append content to the existing file? Like what, and would that have changed? Obviously it would change the file size and hash and so on, but is that something that again, that organizations would even be looking for a file like ethers that may have been on their network for years?
So yes, hashes were changed, the size were changed, but ever so slightly, because Trojanist files had the same code as legitimate files. It just had few lines of code added. So in the first case, the lines of code were like just a few lines. And for the second phase, there were just, a few lines of code that switched addresses, and that's it. So size did change, but it wasn't that noticeable. It would be noticeable if you, checked, if you scanned and if you checked, previous hashes and current hashes, you would notice. But I don't know. Karlo can correct me if I'm wrong, but I don't think that people are scanning softwares
This isn't something
all
that
the
like
time. Yeah.
like a endpoint agent or AV or type of thing, EDR would necessarily pick up.
The problem is that basically you have a file that performs transaction as part of your wallet, and when you replace it with another file that also performs the same transactions, just has a few hard-coded wallet addresses, you didn't change the logic almost. You didn't change logic at all. The file is still communicating with the same endpoints. You're just adding a new parameter. So basically, that value of the address, wallet address, is expected to be different on each transaction. So it's kind of hard for endpoint solution to detect that change, because you didn't introduce anything special except adding hard-coded wallet addresses to code logic, and there's not much to hook on basically from that perspective. And the problem is, okay, you scan that software at one point in time. You aren't likely detecting if most of the solutions aren't looking for changes in hashes. They are looking for changes in behaviors and some signature like detection spots. And here you just don't have much in it. Basically, it takes the original code logic and patches it with one function that replaces address. So not much to detect there.
So this is part of, and this is kind of what the slide is about, this is part of a much larger trend, and we wrote about this in our software supply chain security report for 2025, which came out a couple months ago. But this trend we're seeing of attacks, software supply chain attacks targeting crypto applications, crypto development pipelines, from wallets to, exchanges, really common. Talk about what you all are seeing in terms of, threats to cryptocurrency development.
So in the last couple of months, we have seen the rise of attacks targeting crypto community. Some of the attacks we have seen were targeted some big legitimate crypto-related NPM packages. They were hijacked. Some packages that were targeted weren't maybe crypto-related, but they were hijacked and injected with malicious payload that would steal crypto wallets. We have also seen the rise of simple malwares, but that would steal crypto funds, that would steal maybe crypto wallets or different informations related to crypto community. And we have also seen, different packages, not only on NPM, but we have seen crypto-related malware on PIPI as well. So all that trend targeted NPM, crypto-oriented community also shifted to PIPI. So that has been happening for, I think, a year now, a couple of months or something like that. So yeah.
Yeah, I mean, I mean, obviously this makes sense, right? Because there's a lot of money floating around in crypto wallets and crypto applications and exchanges. So, I mean, from a cyber criminal standpoint, right? Like that's what you're going to be interested in. I mean, like, for example, Lucija, you mentioned, the most recent attacks or campaigns that you identified with this, remote patching. I mean, with this local patching, and the one that you discovered, you know, whatever it was, a month and a half ago. Any suggestion that these are linked, or that this is just, you know, this sort of local patching of, you know, widely used open source files? That's just a technique that's being adopted and embraced by a bunch of different malicious actors. So is there any idea, any sense that you get that these campaigns are all coming from the same place, same adversaries, or not?
So for some crypto campaigns, I can tell that they are coming from the same authors because of the way the names of malicious packages were chosen, or just by the way the code is written. For these two campaigns that were patching files, the code was totally different, and everything, like those two waves and packages were different, but they were so closely together. They were published like a week later. So maybe potentially they are or from the same group, or just, you know, people came to the same idea at the same time, but we are not sure who, or is it widely used trend. We just know that it starts appearing currently, but we don't know who is the behind that patching, malicious patching.
Right. And there were other issues too. Talk a little bit about the Bitcoin library fix that we documented, or the proposed fix.
Yeah, this was again crypto-related campaign. I wouldn't even say the campaign. This was an interesting, I would say, opportunity for malicious actor to hop on some issue that some of the users had with Bitcoin Lib, official Bitcoin Lib GitHub project. So basically, there was an issue opened on GitHub, and somebody quickly responded and said that they provided a fix for that issue, and basically they put a malicious package there as a fix for the solution, and everything happened in just a few hours. So basically, the user opened the issue, and the attacker responded really quickly and abused that opportunity. So that's an example how vigilant those threat actors are. Basically,
that's what was really interesting to me, is that they clearly were you know, following this, you know, this group of maintainers, developers, you know, working on this, saw this, oh hey, we're getting some error messages, you know, around Bitcoin transfers, but you know, the transfers are completing, but these error messages, can we make them go away? And then kind of injected themselves like, oh, here's a fix, like, here, download it. You know, I mean, it's so, I mean, gosh, as a crypto developer, that would make me nervous that they're sort of that vigilant. And I mean, I guess
that's really fast response. And again, I'm not sure if that was totally malicious campaign or
a joke.
When we came upon the issue, some of the GitHub comments were already deleted. Based on the comments, it looked like it started like April Fool's Day joke, let's say, and that then the attacker came, okay, I could have some gain from this, and I'll do it really malicious. So,
but the lessons for developers are kind of the same, right? Because there's all kinds of, like, there's protestware too. It's not technically malicious, but it's unwanted code, you know, with some kind of political message, or, you know, like you said, April Fool's kind of joke, you know. But from a developer standpoint, it's all the same problem, right? Which is, I downloaded this and thought it did this one thing, but in fact, there was a whole bunch of code in it that I wasn't aware of that did other stuff I wasn't aware of.
Right. Yeah, but as you said, they are really quick. Like, it's like pulling your car next to the road and jumping to the traffic shop, and somebody steals your car. So this is basically the same corresponds, same quickness, and
yeah. So one of the other trends, you know, Q1 trends, I think it's worth talking about, is the VS Code threats. There were a couple campaigns that we spotted involving malicious packages on VS Code. And one of your colleagues, I think Pitar, had one of them. And I think Karlo, you discovered one as well. Talk about the VS Code platform and how and this was something else we talked about in our 2025 report, more campaigns targeting VS Code. What's that all about, and what should folks who are using VS Code know?
So up until, I don't know.
Oh, sorry.
Oh, up until a couple of months ago, I think VS Code Marketplace wasn't, there were here and there some malicious NPM packages. We had one malicious VS Code extensions. We had one malicious VS Code extension last year in April. But since September, October, VS Code's malware started appearing more and more frequently. We also had seen, which you can see from the left tweet, we have seen the campaign that appeared first on VS Code, then it proliferated to NPM, and then it returned to VS Code. And the second tweet you see, it's a campaign where, again, malicious NPM malicious VS Code extension was delivering ransomware and making. So basically, VS Code extensions can be potentially maybe dangerous for users, just like ML models, because users don't see them as adding anything to the code. They just see them as plugins for your VS Code IDE. So you just, download VS Code extensions without thinking. But VS Code extensions are essentially NPM packages just wrapped. So like in this first campaign left, you can download some VS Code extension that is clean but has malicious NPM dependency, and that way you can poison your development environment. So, people should know what they are including, and they should educate themselves, just like with ML models. Maybe people don't think of it as potential that something could potentially happen malicious, but it still can happen. So, yeah.
I mean, historically, VS Code has not, when we've written about trends in, open source malware and malicious campaigns, primarily it's NPM, Python package index. VS Code's been, what is that changing, or these are still very rare but are becoming more common? Like, what do you think is prompting these campaigns on VS Code?
Well, the number of malicious packages obviously is not as big as on NPM and PyPI, but I think malicious actors are waking up on VS Code Marketplace, and we are seeing more and more malicious packages appearing on VS Code Marketplace. And we have been for a year now, and maybe a year and a half, we have been tracking VS Code extensions extensively. We are, every day Petar is looking for them, that he's looking for malicious VS Code extensions. And we are also adding VS Code extension support in our Spectre Share community. So you can also see there if some VS Code extension is malicious or not, amongst other things.
So this is the secure.software site, right? And
Yeah.
that VS Code will be added to the repos that you can search for malicious content.
Yes.
Yes, VS Code is one of the most popular IDEs used by script language developers, and you can see how popular it is based on some of the mainstream AI, let's say, tools for automated development and code generation are designed to be integrated into VS Code. That's just another sign how popular that IDE is, and people should look at what they're installing there.
Right. it's kind of another wrinkle or another front in the, supply chain threat landscape, right? Which is, not
Yes.
just trying to sneak malicious code into your development system, but actually targeting the platform you're using itself.
Yes,
to
that's
do
one of
that.
the reasons why we are adding support for it on
Yeah.
OSS Spectre community.
Okay. So first of all, for our attendees, I threw some of those Twitter links in there. If you have a question that you'd like to ask Lucija or Karlo, throw it into the Q&A feature, and we'd be happy to get to it. We're coming up on the end of the hour. I guess one thing, Karlo, what would you, Karlo and Lucija, what would you recommend for development teams, development organizations to do to kind of protect themselves from the types of threats that you all have called out just in the last quarter, both on the Hugging Face side and on the cryptocurrency side? Obviously a lot of the methods are the same that attackers are using now with typo squatting and so on. A lot of the attack vectors are the same. Is there what if you were to advise organizations on how to best insulate themselves from those attacks, what types of things would you recommend they do?
Well, first thing I would tell them to take out from this webinar is to get the sense into their heads that not only open source packages like npm and PyPy, which truly carry code and executables, are the source of the risk. Have in mind that other tools you are likely using and will be intensively using in the near future related to AI can smuggle malicious code and malicious functionality into your development environments without your knowledge and sense. Be aware of those type of threats. Be aware that all the tools and extensions you install should be treated like potential source of malware. That's about the most important thing to take out from this webinar. And the second is watch out if you're developing anything related to cryptocurrencies. That's one of the main threats currently out there, and you are one of the biggest targets for one big group of threat actors, because most of them are looking to gain financial money, not so much
Right.
botnets or anything like that anymore.
Right. We've all seen what's happened to the price of Bitcoin, so that's obviously a huge incentive. Lucija, anything to add to that?
I think I agree with Karlo completely. I just think you should be, mindful and know what you're including in your development cycle. Be aware, scan things. If you have expertise, you can do it yourself. If not, there are tools for it. So, yeah.
It seems to me like a lot of the attacks really rely on or have this presumption that developers are going to be rushed, that they're going to be looking for kind of quick solutions, grab code and use it to solve a discrete problem that they're, trying to develop, solve in the development cycle they're in. And that a lot of these attacks kind of play on that, like count on them just grabbing stuff and pulling it in without, interrogating it, without investigating what they're actually grabbing. Is there an easy way around that? Because a lot of this is just human nature, like I want to get this assignment completed, I want to get it done on time, I want to get it done with kind of minimal effort. You, as a development organization, how do you fight that type of thing?
Well, it's hard for developers because every corporation employer is expecting you to always be more productive. And if you want to be productive, you definitely want to make your life easier. And in most cases, people trade off functionality in favor against security. And it's up to development organization to promote secure programming and security hygiene in development process. And that's something that needs to be put from top onto developers and not expect them to just come to it.
Yeah. One thing we should point out is that there is the Spectre Assure community secure.software that is a free service for some, and there are premium parts of it as well. How could developers utilize a tool like that to help them assess risk and as they're working, through a project?
So currently, there are 4 communities there: NPM, PyPy, RubyGems, and NuGet. We are also adding VS Code Marketplace soon. And basically, they can search any package they want to include in their development cycle, or they have already included in their development cycle. And they can obviously check if it's malicious or not, but they can also check for some issues, vulnerabilities, to maybe see if what they are including in their software and development cycle is vulnerable. They can also see some behaviors and what package does, so they can maybe educate themselves what is happening with the package, that they can be more aware what they are including in their development cycle. And yeah, I think
And
that's
here on the
more or
screen, we've
less
got,
that.
yeah, we've got the
Yeah.
PDF to Office package, and it kind of shows you what would be what you'd be looking at. Of course, there's more that you could scroll down and see. So it's not all of it, but as you can see, obviously detected malware, also some exposed secrets, and yeah, kind of a big red flag if you were to look for this, right?
Yes, this is actually the package from the second wave of the
second
patching.
wave, that's right.
Yes.
Right.
Yes.
Right. It posed as a conversion tool for PDFs files to Microsoft Office,
Yes.
but in fact,
It
wanted
actually
to hijack your
tyrannized.
wallet.
Yes. Yes.
Cool. Okay. If there are no questions, I think we're coming up on the end of the hour. Just wanted to highlight for all of you that we've got some more webinars coming up, as well as some webinars that you can watch that we've already done. Something to put on your radar, definitely. AI Meets Software Supply Chain, April 24th. This is with Dan Petrillo, who's our Director of Product Marketing, and Daniel Miesler, world-renowned expert authority on AI, and a really interesting guy. And then we've got 6 reasons to upgrade from OpsWatt. It's a webinar we're doing on April 23rd. We mentioned, of course, the 2025 Software Supply Chain Security Report. You can download that from our website. And we've got a white paper on modern malware analysis as well. So with that, if there are no questions, Karlo and Lucija, I want to just ask you anything else to add before we break. You're good. I wanted to thank everybody for joining us. And of course, Karlo and Lucija, thank you so much for the amazing work that you do. And I can tell you for sure we'll be back again next quarter for our Q2 Threat Research Roundup. And really interested to see what you guys come across.
Thank you, Paul, for having us.
Thanks, Paul.
It's a pleasure. Thanks, everyone. And check your email inbox. You'll be getting a link to the video. And remember to fill out the review form. Thanks.